Hello students, in this video I am going to go over two examples related to graphs of inverse functions. Let's take a look. The first question here doesn't really involve graphs. However, you do need to have some graphical understanding of the relationship between inverses and its function and its original function, and that is all the points in the original function will be reflected over the line y equals x. So to demonstrate this, okay, I'm going to turn this into graph paper. Hold on a second. All right, so to demonstrate this, okay, I'm going to draw myself an xy axis. Again, you do not need to do like the full extent of this. However, for the first maybe 2 or 3 points, okay, that's what I'm going to do, okay? So the first point is 2, 8, so it's 2, and then 2, 4, 6, 8. It's located over here. Next is negative 6, 5, so it's negative 2, 4, 6, 2, 4, 1. It's located over here. Okay, so I'm just going to graph these 2 points. Now what we're going to do is we're going to reflect this over the line y equals x. So that's y equals x. So when I take this point, which was at 2, 8, and I reflect it over the line y equals x, what I'll get is a point that's located over here, right? So this is my new point. And what is this point? Well, this is 8, 2. Well, let's do that again, okay? If I take this and reflect it over the line y equals x, let's see here, 2, 4, 5. So it's 2. I believe it's right here. Okay. So this original point is at negative 6, 5. The new point now, let's see here, 2, 4. I miscounted. Whoops. The new point now is located at 5, 2, 4, 5, and then comma 2, 4, 6. All right, so what's the pattern here? When I reflect something over the line y equals x, the x and y coordinates gets reversed, which is why the domain and range, right, are flipped between the inverse function and the original function. So to answer this question, find the inverse of each relation here. So what I have is, it's going to be 8, 2, negative 6, I'm sorry, not negative 6, 5, negative 6, 2, 8, and negative 6, 5. So these are the points in the relation. That is the inverse of this relation. All right, let's take a look at another example. Here we need to find the inverse of each function and then graph the function and its inverse. All right, so to do that, okay, I'm going to replace f of x with the letter y, right, or a letter f. 7x minus 4 over 8. I'm going to try to isolate x. So I get 8f is equal to 7x minus 4. I'm going to add 4 to both sides. 8f plus 4 is equal to 7x. Divide both sides by 7. I get x is equal to 8f plus 4 over 7. And then the last step is I replace x with f and f with x. But understanding that this f here is the inverse of the other, right? So this is the inverse function. Okay, so now that I have this, I'm going to graph the two of them together. And this is rather complicated to graph, I'll be honest with you. So this guy right here, whoops. So this original equation, okay, just by looking at this, I can tell, okay, that the slope is located at is 7/8. The y-intercept is -half, which is kind of a bummer to graph. So what are we going to do to make this like a little nicer? What I'm going to do is I'm going to try to find a point that that I can use and try to graph this in point slope form. So I want to, let's say right now, okay, I want to turn the numerator so that it's equals to 8. So at what values of x will cause this all to equal to 8? So let's say 7x minus 4 is equal to 8. No, that would be a bad choice. Hold on. So what would we do to make this a little nicer? To make this a little nicer, I guess I would put in something that is going to be a multiple of 8 so that I can then graph this at a particular point. Or you know what? Maybe the strategy is to just punch this in and graph it as is, I guess. So at -half, okay, I want to go up 7. So it's going to be 1, 2, 3, 4, 5, 6, 7. And then I'm going to go over 8. So 1, 2, 3, 4, 5, 6, 7, 8. So I will be right here. Boy, that was tough. Apologies for the slight hesitance there. Okay, so anyway, those are the 2 points, and that's all you really need actually. So I want to take that. Okay, that's the equation of the original. Now I need the graph of the inverse, right? So the graph of the inverse, unfortunately, it's not going to be any easier. So what we're going to do, okay, is we're going to apply that understanding of what we just went through with this example up above, and that is I'm going to perform a reflection of these points. So this y-intercept becomes that x-intercept. This point over here, which was at 8 comma, let's see, what is this? 2, 4, 6.5. At 8 comma 6.5. When I reflect it, where am I going to end up? I'm going to end up at 6.5 comma 8 then. So 2, 4, 6.5. It's located here, comma 8. So it's 2, 4, 6, 8. So over there. So if I go like this, it's going to be right there. Okay? And what I'm going to do is I'm going to thread a line through those two. And how's that going to look? It's going to look like this. Okay? And there you have it. Okay, the two lines, okay, are reflections of one another over the line y equals x.